Well, good afternoon, everybody. Thank you for coming in. Looking forward to hearing from Dr. Naveed here in just a few minutes. Just wanted to take a second and introduce him. I've worked with him for now the last couple of years. Autodesk has been a Domo user since 2014, one of the early adopters. And before Dr. Naveed worked at Autodesk, he actually worked with Domo at the company before that he had worked out. So anyways, looking forward to hearing what he has to teach us and share with us as it relates to a playbook on machine learning and Domo. So without further ado, Dr. Naveed, if you'll come on up here.
Thank you for the introduction. Hello, everyone, and sorry for the delay. So since the room is mix of probably technical and non-technical people, I try to balance the presentation between technical and non-technical stuff and focus more on the process rather than the actual technical things. So I do apologize in advance if it's boring for you or if it's too high for you. I try to balance it again. Another thing that my co-presenter, Dr. Rizvani, unfortunately, she was not able to make it here due to unforeseen circumstances. So I'll go solo on this presentation. So after the introduction, I'll try to describe the project and what are the things that we had done throughout this project, and then go through the project phases, and I'll run you through the takeaways, and then we'll have the Q&A after. So when I started the work in Autodesk and focusing on data science prior to that, there was a joke going around that who is a data scientist? I think we didn't get it right yet. I was living in San Francisco back then, so I thought, okay, I have 50% of the things, I know statistics, I'm not a statistician, I know statistics, so I could be a data scientist. That's why, I took that role. And, on the left, you can see me, so it's about 4 years that I'm in Autodesk. And it was the thing that I'm presenting was a group work. So in the middle, you can see Shaheen, which is a PhD candidate in Texas, and he helped us a lot. He's a PhD candidate in mechanical engineering. And on the right side, you can see Dr. Rizvani. She has PhD in civil, and we worked on construction workflows all together. And she brought the domain expertise, and all together, we tried to solve the problems for Autodesk, specifically for construction business line. So project description. So we started this effort about a year ago. Last year in Domopalooza, we tried to see what's out there in terms of data science and machine learning tools that we can use. And we identified that the things that are out there is not sufficient for our needs and cannot answer the questions that we had. So we tried to take the initiations ourselves, and that's why we have this project done. And as you know, there are some tools now available, like the machine learning tiles in Domo, but the approach that we took and the playbook that we are going to go through it today, was a bit different. So this is a code that if you torture your data enough, it's going to confess. Actually, the complete code says it's going to confess to anything. So we try to take it, try to torture our data to answer the questions that we had. We did it in two phases. The first phase was really data preparation. And as I'm going to walk you through it, so in the first step, we tried to democratize the data that we had from different sources that we had and make sure that the data is available to everyone inside the company. And then, we try to use Domo as our data repository. One of the good things about being part of an enterprise like Autodesk is you have access to many, many tools. But for this exercise, we decided to have all of our data available and our ETL available in Domo in particular, use it as a data warehouse. One of the beautiful things that Domo offers is you can use it for data, ingestion and data preparation you can do the analysis right there, and you can do the visualization, right there. So it's a one-stop shop for technical and non-technical people. That's one of the reasons that I love Domo, and that's one of the reasons that, I continue using that. And then in the second phase that I will walk you through it, we try to drive insight. And essentially, what we did was, implemented our machine learning algorithms there to get to the result that we need. So that's why we designed this playbook, and that's what I'm sharing with you guys. So it has 3 major steps. The first step is the data preparation, how we did it, and how you might want to do it, and take that approach. The second phase is to get the insights and the actual machine learning process that we went through it, and how we took our data out, trained the models, and ingested it back, and then made it available to everyone. And obviously the last step is visualization. So let's start from the first step. So I'll give you a second to read this. In data science, 80% of time is spent on preparing data, and another 20% complaining about that. That's a reality, unfortunately. And you have to go through that. No data science project happens without making your data clean and tidy and make it available so you can ingest it to your algorithms, as you might know. So what we did. For data preparation and for the first phase, what we did is we essentially had Domo as the central point of everything, and then try to bring data from different sources that we had. Was like 100 different sources. So we had to put all of them together to just begin to make sense of our data. But how? So the first thing that we started with was to bring the usage data that we had from different Autodesk products through SFTP and through Mixpanel. That's the next step I will talk about it, and through S3. So as you may know, Autodesk has more than 200 different products. And my focus and my team's focus was on construction business line. And construction for Autodesk is huge. As a matter of fact, the way that our CEO put it, is that that's the future. And the way that our CMO put it, it is what makes Autodesk thrive and survive in future, because that's one of the biggest industries that has not been tapped into yet, and there are a lot of opportunities there for automation and making construction better. As a matter of fact, one of the keynote speakers, I think he was the first keynote speaker, was from Leighton Construction, and they are one of our biggest customers in Autodesk too, and they're using our products. So we got usage data from multiple products, the usage tables, the fact tables, and dimension tables, put into SFTP and put into S3 buckets, and then for some of them we collected click streams through Mixpanel. And then after that, we brought in our Salesforce data, brought in some of the SQL data that we had on different tables that was available. Major things that we brought in was the reference tables to say, for example, if an account is a trial, a paid, what's the type of account, what's geo, things like that. That wasn't necessarily available on Salesforce, and we used API calls to ingest some of those data. Then we brought our marketing automation data and click stream on our website for pre-sale into the picture too. So the other things that we had was for post-sale, and this part was about pre-sale. So we wanted to put all of them together to have a better understanding of customer journey and to answer the questions that I will go through them using data science and different algorithms that we had available there. And the result was a massive table that's timing out for us now in Domo, and we constantly are trying to make it better with like almost 100 million rows that, as you can see, around 700 cards is attached to only this data set, and it's been massively used. So essentially, it's like a funnel. All of the data that we had, uphand is going down through our ETL process to this one huge, humongous data set, in talking about Domo's, terms, not huge in big data sense. And, coming out and being spread to the team to use, this through like, again, 600 cards and a lot of other, data flows and cards that being used. So the problem that we faced was this. So we had so much data available that people were lost in it. And essentially after doing all of that work, making data prepared, making it available, putting all of those data sources together, now we face this problem that people were not making sense of it. It was too much for them, and they were just ignoring it. So we thought we need to go deeper. And as a matter of fact, Inception is one of my favorite movies because it's like data science. The deeper you go, it's bigger, and you will have chance to understand it better. At the same time, you get lost. So we get to the second step of the process, and we wanted to drive more insight to answer the question. And that was the major step of our playbook. After the data preparation, making sure that your data is ready, it's tidy, it's clean, all of the data, all of the features that you want, all of the columns that you want are available in your data set. Now it's the time to get insight from your data. And as a matter of fact, the thing that we started using was machine learning. Initially, we thought, okay, it's easy. You'll put some of the machines in front of the others, and they'll learn from each other. It wasn't that easy. So, after we pulled data from Domo in the second step of our playbook, we pulled data out of Domo, try to train the model both on the local machine and then later on after the proof of concept was done in our other machines and servers, test the model to make sure that it works and essentially do the predictive analytics and then push the data back into Domo and create the visualizations that we needed. So just 1 minute on what we did and 1 minute on what's the difference between classification and other available options and algorithms in data science. So this is an example that I found on the internet. I like the visualization. There are a bit different methods that you can use. If you take classification, the result that you get from your data science algorithm is pass or fail. If you do other things like, for example, regression, you can get more numeric results, as you know. Some of the things that we had done, were actually, as a matter of fact, the majority of the things that we had done was in classification. So that's why the algorithms that we adopted and worked on were focusing around that. And in the next slide, I will go through use cases and how we've done it. And there were classification rather than trying to get to an actual number. So the first use case that we had, the first use case was churn prediction. As you may know, churn prediction is huge for you if when you're. So there is a study out there. It says acquiring a new customer is, if I remember correctly, like 8 or 9 times more expensive compared to retaining your current customers. So that's why it's so crucial for us, to make sure that our customers stay with us, they are happy, and both logo churn and also ARR churn for a cloud business like ours that's on subscription is very important. So we wanted to answer both of these questions and understand how we can predict churn and how we can make sure that our customers are not churning. So what we tried to do was through XGBoost algorithm, we tried to first pull data from a specific data flows that we had. The major data point that we had, the major table and data set that we had was the data set that I initially showed it to you guys, and it has like 400 million rows. So it has all of our usage in it, and from different products that are for construction. So what we did is we brought all of the features that was important for us. Like for example, we wanted to know if our construction service providers are more successful and they stay with us, or they are designers, or there are architects, or for every single one of our products, we wanted to know who uses the product better, and based on that usage and different features that was available in our data set, and we made it available, who is going to churn, who is going to stay. And on the right side of the screen, you can see the actual result of it, for I think it was like for 2 months ago. So this is the ranking that our model presented. Unfortunately, we had to hide all of the actual data, and this is the actual result. So we, our model was predicting that these customers are going to churn, and the red ones show they actually are churned, and the green ones stayed with us. So it was more of a ranking rather than an actual prediction of churn or not churn. So it's again, this is a ranking that you see. So what we had done after our prediction, we pushed the data back into Domo and made it available to our sales team, to our customer success team, and as a matter of fact, we made that available in our Salesforce instance too. So for our customer success team, they use Gainsight, and through Salesforce, we made that data available into Gainsight for them. So like 3 months down the road, 4 months down the road, they know who has more chance of churn in each given month, and they start working on them to make sure that they're not going to churn if there is a chance for it. But there was another major use case for us. I brought this chart from a company called Tatango. I don't know if you're familiar with it or not. They're a customer success platform, and I like them a lot. In Autodesk, we use both Tatango and Gainsight. There are competitors, but we use them both for different products and different parts of the organization. So there are studies suggesting that if you don't onboard your customers well, there is a very high chance of cancellation. And on top of that, if you don't nurture them well, there is a very good chance of cancellation. So if you expect your customers to renew and then expand later, this is all part of the same journey. It is not, it's not separated. So as a result, if you don't do your job well in the onboarding phase or in the nurture phase, they're going to cancel. They're not going to stay with you, no matter how good your churn prediction model is. If you don't, the major predictor of churn, if you look at the customer lifetime, is going to be the onboarding. So that's why we took on this project in the next step in 2 different phases. In the first phase of it, we wanted to know what a sticky customer does. And if they come on board based on their persona, and by persona, I don't mean marketing-defined persona. I mean, the clustering and the clusters that we can define for our customers, so for our users. In construction, it's a bit different compared to other B2B businesses. So we have the user, we have the project, we have the customer, and in many occasions, the customer have multiple tenants. Like, for example, they have a tenant in the US, another tenant in the UK, another one in France, another one in Germany. So all of them are part of the same customer. And then we have different Autodesk products that they can use for, let's say, design phase, pre-construction phase, construction phase, and after the construction handover and then maintenance. So we have designated products for each each one of these phases. And it was very important for us to have a unified customer journey, user journey, not customer journey, for all of those, and to make sure that we have a very good understanding of how we can define a successful user, and then make sure that when we onboard users in particular, and then projects through project admin, we put them into the path of success. That's why in the first phase of this project, we first defined personas through clustering, and then by working with our experts, based on expert opinion, we try to put definitions on those personas. So data says something, then we take it out to experts to say, hey, data says this. Do you think in real world, this data set, these features represent a real person or not? And they said yes. As a matter of fact, it made a lot of sense to them. And we have been able to put names and assign roles inside construction companies to those personas that we got through our clustering effort. And then in the next step, we try to understand, each one of the personas, each one of the clusters, what are the things that makes them successful, makes them sticky, and make sure that, we pass those functions as priorities to our product managers so they can make the products better. As a result, we had dashboards specific to product managers that we take the data out, train it, cluster it, and then through decision tree algorithms, we understand what a successful user does, and then push it back into Domo for visualization and show it to our product managers. And our product managers are some of the heaviest users of Domo among other users, specifically for our platform product, which is called BIM 360 Docs. So another thing that we had done was on the same note, we wanted to understand what's the path to success for them. This is not a visualization done in Domo, I have to mention. This is a separate visualization, but the data was coming out of Domo, and through the same process, we trained the decision tree to understand it. And this data is pruned, so that's why number of nodes is not the same for all of the, might not necessarily be the same for all of the branches that you can see here. So we try to understand what's the dominant path to success for different products that we had. As I just mentioned, in the user level, it was different from the project level, from the account level. In this use case, we focused on the user level and the project level again through project admin. So we ran this algorithm a couple of times, actually a couple of different versions of the algorithm, and we retrain it constantly to make sure that the data is available, to our customer success team for their onboarding efforts, and make sure that the playbooks that they have and then define either into Tango or Gainsight are based on what data represents. So what we had done is first and foremost we defined success for our users. That's the major challenge. That was a major challenge for us. We went through so many interviews with our experts to build a hypothesis that what a success means, because we wanted to go through a classification and essentially understand if a user is successful, is good, or needs improvements. So for that, it's a classification, and to train our model, we needed to have a label for our current data sets. And to put that label on, we went through 6 different versions of it. We started with a hypothesis of what success means, and based on that hypothesis, we ran the algorithm. Unfortunately, it wasn't satisfactory, and the results didn't make sense. So we went through this iteration. We went back to them and redefined the success for 6 times. Simple question that doesn't seem to be very hard to answer. It became one of the hardest questions that we had to answer before replicate the success for other users that we had. So we sat with them, defined success for the 6th time, ran the algorithm through decision tree and random forest, and defined all of the nodes. And then we selected the control group and a test group, and then we ran through a POC with them. And our test group proved 300% improvement in the usage events when they went through the onboarding that was the result of this. So again, we defined the path to success, dominant path to success based on the user persona for each product. And then for onboarding, we defined like 7 different things and thresholds that they have to go through. And we went through this POC to show 300% uplift in usage events. After we showed that this works, we made this data available to our customer success team and customer engagement. There are 2 different teams in Autodesk. They try to modify all of the user onboarding. Then we ran through this again for our trialers, for pre-sale, and made sure that we understand what trial success means. And based on that, we did something that, as far as I know, nowhere else it has been done. And we modified our trial nurture campaigns with marketing department and made it behavioral based. So essentially, instead of just having a drip campaign, day 1, day 2, day 3, day 5, day 1 they receive this email. We look at their behavior and then customize the second email completely. If they have done, so we identified like 7 different steps that they had to go through it. And if they have already done that, if they have already gone through the second phase, action event, we just skipped that, went to the 3rd, went to the 4th, went to the 5th. And if they already have done all of those, we just pass it to sales as a marketing qualified lead. So they take it on and work with them no matter how long had been passed from their trial. So then in the last step of our playbook, what we did was to make sure that all of our visualizations are available to different individuals and different personas inside the company. So we, our aim was to create and certify dashboards and cards for different roles inside the company. PMs versus customer success managers versus sales versus, executives. They are, and we're relying on our dashboards, for all of their reportings and operations. And for example, specifically, I don't know if you guys know or not, so since construction is in the focus for Autodesk, our CEO decided that construction has so much importance that it has to be a completely separate unit under the CEO himself. So we have a business group for construction, and the lead of the construction group, is kind of essentially is the CEO of construction that reports to Andrew, our CEO, and the board directly. So our general manager or VP of construction, his name is Jim. He relies on the dashboards that we have, to report to our board for construction business line performance and everything that's important for Autodesk. Autodesk, these are public numbers, spent like $1.1 billion last year for acquisitions to bring more products inside it. So that shows how important construction is for Autodesk. And again, our VP of construction just relies on the dashboards that we have on Domo to report to our CEO, and our finance relies on those dashboards to report to the street. Autodesk is a public company, and the numbers that they publish above and beyond, the non-financial numbers that they publish, to street, comes from our Domo dashboard. So that's why we need to make sure that everything is very accurate. It went through multiple iterations, multiple reviews, and make sure that all of the numbers are accurate because they are going to be put on the decks, on the numbers that's going to be reported to the street. So we were under a lot of pressure to get it right. That's why we try to make sure we're using as much visualization as possible. I'm not going to go through all of the visualizations that we had. I just brought a few samples, here. So you can use how our predictive models and, things were being presented to, different personas and different individuals that we had inside the company. And as a result, someone approached us and say, hey, I'm going to leave you to read it yourself. You may get it or might not get it, So we decided to do better, that's why, the work is continuous, and that's why it's just the first step of the thing. Everything is in production for us, but it's just the first step of it. So what's the takeaway for you guys? I tried to walk you in a very high level through the playbook that we went through it. And this is the playbook in one snapshot. So in the data preparation phase, to reiterate, you prepare and gather all of your data in one place to make sure that it's tidy, it's clean, all of the features that you need to run your algorithms is available there, and essentially there is no other work for you after you push the data out of Domo, or at least this is what made us a bit successful, and the work that we had outside of Domo wasn't wasn't focused on data preparation. So everything on the data preparation was done inside Domo, and then we had mechanisms in place for error detection, for making sure that all of our data flows, the ETL process, everything runs very smoothly, and there is no problem with that. Then in the second step, which is the actual data science part of it and the machine learning part of it, we pulled data out of Domo, trained the model, initially inside of our local machines for the proof of concept. Then after that, schedule it through, servers that we set up. For every single new algorithm, we tested the model to make sure that they work correctly, and then after that, we remove this space. The prediction is done through our algorithm, and then we push the data back into Domo. Again, this was before the data science tiles was available in Domo, so there are some limited work that you can do there, and the scripting tiles also, they have their own limitations as far as I played with it, so you might not be able to do a full analysis like this using those, but some steps, could be done there if you're not, technical enough to do them. And then you push the data back into Domo for visualization. And in the visualization part, we developed certified dashboards and cards for different personas, different individuals inside Autodesk. And as I just mentioned, make sure that the dashboards are edited and appropriate filters and appropriate views are available to appropriate personas. So essentially deliver the right data to the right person inside the company, and then schedule delivery via email and other delivery methods. Unfortunately, not everyone inside Autodesk is a Domo user. Autodesk has like 11K employees, and we have a limited number of seats available to Domo. So we had to use this workaround on creating social users, and then deliver the reports that was appropriate to them via email. So obviously not all of the functionalities of Domo is going to be available there, but you can get the dashboard, an overview of the dashboard, and get the numbers via email if you schedule email to go out to them. And they are on a free tier. And then that was it. So I'll leave you to read these to you. Thank you so much for your time. I unfortunately had a flight to catch, so I had to cut short a little bit on my presentation and eliminate some of the details. So I'm going to open it up for questions. And if there is any question, I will try my best to answer it. Go ahead. You probably need the mic.
Test. Yes, I'm wondering what your favorite tools are for doing data modeling outside of Domo.
Outside of Domo?
Yeah.
So as I mentioned, we push the data out to local machines. We use Python, to write our code, and used it there, to use the local machine, then later on server through Python to train the model. It wasn't a complicated thing. It was just Python coding and using the appropriate libraries there.
Okay.
Just a quick question. I have two questions. Both are related to the same topic. So you said you have built a massive table of 300 rows and which powers like 700 cards. So why build around 300 rows, a massive fact table, rather than when you can actually do a data modeling and
300 million.
Yeah.
Yes.
No. I mean to say, so you're dumping all your data into Domo, and you're mainly using Domo as your warehouse. How would you look at the point where once your data is in Domo, you're limited to the capabilities what you can do within the Domo,
yes.
rather than, for suppose, if you have some other data warehouse like Snowflake or coming up new Redshift or Google BigQuery, where you can do modeling within Snowflake, or it actually, like, you can have slowly changing dimension tables, type 6 or type 4, and then push them to the modeling, and then only pull the final prediction results into Domo just for the visualization. ETL can definitely be much better if you're doing it outside Domo.
Yes.
So how would you say, what have you used, why have you preferred doing it within the Domo but not outside Domo, or you just started to do it
So
really quick?
After we ran through this project, we showed Autodesk, we were a team of 2 and then later on 3. So we didn't have a data engineer in our team, and as a result, we were more of data scientists rather than data engineers. And again, the resources were really, really limited. So we had to show to the team, to the management team, that this works to get extra resources. Now we have like 7 more headcounts because of these projects, and we have resources like that. We are, right now, as we speak, we are studying other options, to see if it is better for us to go with Snowflake or Redshift or, Google BigQuery. These are the 3 major things that we are looking at now, and you're absolutely right on the spot. It's much better to do it there, but we needed resources to do it. So as a result, since we didn't have resources and we had our day-to-day job to do before this project, we decided for the amount of data that we have, it is better for everything to stay in Domo for the time being, then later on we find other solutions.
Yeah, makes sense. Yeah.
Okay. Mike is coming.
Thank you. How are you pulling or extracting data out of Domo? Are you using a automation or
just Domo APIs? We have our servers, and we have cron jobs there to pull data out of Domo through their APIs.
So it's external.
We have other summary tables, on top of our actual table to make the data prepared for our algorithms to run. Mm-hmm. And then the data is much, much smaller than 400 million rows of data there, for our data science project. So, we prepare the data and just use APIs to pull it out.
APIs, okay.
Yeah. Okay. Thank you, everyone, and have a great day. Oh, there is another question. Okay, we can.
Yes, so I actually had kind of a question on the first use case that you had on the churn probability. So could you walk me through just like the process of how you ended up determining, based on historical accounts, did you use like some sort of customer profiling to identify the types of customers that you would consider to be churn, and then if you did do that, what was your kind of process internally of determining those profiles?
So we added, as many features as was available for us based on, the company income, the company size, number of projects that they have, IT spend that they have, and anything was relevant, based on expert opinion after our interviews to make sure that we have all the features that we think is relevant to a customer, and our experts think, because of that, the customer is going to stay with us. So there were financial and non-financial features that we added to our data sets, and we enriched our data based on that. And then we started labeling, different data features, based on, like, for example, the company size. Initially, we had number of employees, and then we thought it's too much in our model. We replaced that with small, medium enterprise companies and things like that, or the industry type. If they are, like, again, construction provider, if they are major design provider, if they are architect company, and things like that. And then we enriched our data set with all of the features that was available, and then ran the algorithm on top of that. Yeah. Okay. Thank you, everyone, and have a great day.